Hello students, welcome to my new video. So today we are going to discuss about a very important electric device that is known as a potentiometer. I have often seen students, they are having a lot of confusions and doubts regarding this particular device, potentiometer. So first we are going to understand the basic concept of a potentiometer and what it actually does. Okay, so let's start. So see, potentiometer, first of all, you have to understand what is this device and what is the basic utility of this device. So basically, potentiometer, it measures the potential difference between any two points. Okay, first this point has to be very clear. So here I am writing, it is a device used to measure the potential difference Okay, so it is used to measure the potential difference between any two points of an electric circuit. Between two points. Okay. Now, to measure the potential difference between two points in an electric circuit, I hope all of you have heard the name of one more electric device that is known as a voltmeter. Now, what is the difference between a voltmeter and a potentiometer? You see, voltmeter also measures the potential difference. Okay. Now, if voltmeter also measures the potential difference between any two points, then what is the utility of this potentiometer? Okay. Now see, potentiometer is much more accurate than a voltmeter. Okay. So later on in some other video, I will be telling you how to construct a voltmeter or what is the internal mechanism of a voltmeter. So if you learn voltmeter, you will understand that voltmeter is always not 100% accurate. It will give you the potential difference between two points, but it is not 100% accurate. But on this particular device, potentiometer, it is much more effective and much more accurate than a voltmeter. Okay, so potentiometer is more accurate than a voltmeter. So potentiometer is much more accurate than a voltmeter. Now the question is that if potentiometer is much more accurate than a voltmeter, then all the students who have been doing practicals in physics practical, to measure the potential difference, always you use voltmeter. Now why is this case? We can use potentiometer. You see students, potentiometer is it's a very big device and voltmeter is a very small device. So voltmeter is easily, it can be carried from one place to another place and it is very easy to use. You can just plug on the 2 points and the voltmeter is going to directly give you the reading. But in the case of potentiometer, no doubt it gives you a very accurate reading, but over there the reading of the potential difference you will not get directly. You have to measure, okay? You have to measure the potential difference. But on the other hand, voltmeter, if you just plug on the 2 points, if you just connect the 2 points, whichever 2 points you may be wanting to find out the potential difference, the reading, the scale over there, it is going to directly give you the potential difference. That is why in all the physics practical that you have been doing, we use voltmeter. Though we know that voltmeter is not exactly 100% accurate, but still we can compensate on that and we use voltmeter. But over here we are going to learn about potentiometer and see what is the basic utility and function of a potentiometer. Now before that, in most of the books I have seen that for potentiometer, they dive directly into the uses of potentiometer. Okay. Now see, what are the basic uses of potentiometer? So first of all, number one, it measures the potential difference. Okay, so this is the basic function of a potentiometer. It measures the potential difference. Okay. So the second function is potentiometer. It can also be used. It measures the EMF of a cell. Okay, so potentiometer can also be used to measure the EMF of a cell. I hope all of you know what is the meaning of EMF of a cell. Suppose you have a cell and you don't know the EMF of the cell. With the help of this potentiometer, you can easily measure the EMF of the cell. Number 3, it can compare the EMF of two cells. Suppose you have two cells and you want to compare the EMF of the two cells, okay? So that is also one more function of potentiometer. And one more function of potentiometer we have, it can measure the internal resistance of a cell. So it can measure the internal resistance of a cell. I hope all of you know what is the meaning of internal resistance. So potentiometer can also measure the internal resistance of a cell. So these are the basic functions of a potentiometer. Okay. So first of all, it measures the potential difference. It can measure the EMF of a cell. It can compare the EMF of two cells, or it can measure the internal resistance of a cell. Fine. Okay. And most of the books I have seen, they go directly from here, how to measure the internal resistance of a cell. But in this video, we are not going to discuss that one. In this video, first we are going to understand the basic concept of a potentiometer and how does a potentiometer actually work. Okay. So we are going to start with this one. How does a potentiometer measures the potential difference between any two points? Okay. So this, suppose I have a battery over here. This is a battery. I am drawing a very simple circuit. This is a battery. Okay. Suppose the name of the battery is B, and we have a switch over here called key. Fine. Okay. This is suppose point A. This is suppose point B. Now, this is a normal copper wire that we use in normal circuit, okay? But in these 2 points, A and B, we have a very special type of wire. This is not a copper wire, we have a very special type of wire, this one. This is not a copper wire. Why I am telling students this is not a copper wire? Because for copper wire, we take the resistance. Since copper is a very good conductor of electricity, we take the resistance of copper wire to be 0. It's exactly not 0, but we take the resistance of copper wire to be 0. Resistance of copper wire, we take it 0. Okay, so we consider that the copper wire has no resistance. But over here we have one, this is not copper wire, this is a wire made up of any other material which has a particular resistance. This wire has a particular resistance. Okay. Now this particular thing is itself a potentiometer. Now students, don't go at first when you are understanding the concept, you don't go to any complicated diagram. First you have to understand the basic design of a potentiometer. So this particular device is basically a potentiometer. Okay. Now let's see how does it measure the potential difference between any two points. Okay. Now let us consider that this length, the length of this one is L. The length of this one is L, suppose. Okay. Now since this wire has a resistance, this wire is of uniform area. Okay, few things you have to keep it in mind. The wire is of uniform area of cross section. Okay, so the wire is of uniform area of cross section. Fine, and the wire has a resistance. It has a resistance. It is not copper, so this particular wire has a resistance. Okay. Now that's why I have drawn this wire with blue color so that you can understand this is a different wire, not this wire. This is a different wire. Okay, so very simple circuit I have drawn. So this battery that I have taken, this battery will be having a certain EMF. Right? So let us suppose this is a 50 volt battery, or suppose 10 volt battery, or 20 volt battery. And suppose this battery will be having a certain potential difference or EMF. Suppose this is V volt I am considering. Suppose, okay, or 50 volt maybe. And this is 0 volt suppose. So the potential difference or the EMF of the battery is V. Now see, this particular this particular point is connected with this point. Okay, and this is a copper wire, and we know through copper wire if we go, there is no drop in potential because copper wire has zero resistance. In the beginning only I say consider that the resistance of the copper wire is zero. So if this is V volt and if there is no drop in potential, so point A also will be in V volt. This point A also is in V volt, right? If this is in 0 volt and if this is a copper wire, so here also will be there is no increase or decrease in potential. So this particular point will be in 0 volt. Right? Now see, as you go along this wire, okay, as you go along this wire, there is a drop in potential from V volt to 0 volt. Right? Suppose this is 50 volt, this is 0 volt. So as you are going along this wire, there is the potential drops continuously from V volt to 0 volt. Right? Okay. Now I have considered that the length of this wire is L. Okay. So see what I am doing over here. In length L, how much is the potential dropping, or the potential difference I can write equals to V volt. Okay. So in length L, the potential drop is V volt. Okay. Now suppose I want to measure the potential difference between these 2 points. Okay, A and suppose this is C. So here I have marked one more point, that is C, and I want to know the potential difference between these 2 points. Okay, suppose the length from this side is X. This is the length from this side, X. Okay, so in length L, the potential drop is V volt. So if I tell that in length 1 means 1 centimeter or unit length, 1 means unit length or 1 centimeter. Okay, so the potential drop will be how much? V by L. Okay, this will be volt per meter. Fine. So in one length, that means in unit length, how much will the, so that means in length L, the potential is dropping by V volt. So in unit length, how much the potential will drop? V by L. Okay. I want to find out the potential difference at this point between A and C. So the distance between A and C is X centimeters, suppose, or X meter. Suppose this is meter or centimeter. Okay. So if in unit length potential difference is V by L, so I can write in length X, potential difference will be V by L into X. Okay, and that's how it is done. Our job is finished. Our job was to just find out the potential difference between these two. So the potential difference in length X equals to V by L into X. Okay. Now you might be wondering how we will know the value of V by L into X. Okay. So see, X distance, if you want to find out the potential difference between point A and C, so you have a scale attached over here. Okay, so easily you can find out that from this particular point up to how much distance I want to find out the potential difference. Suppose at a distance of maybe 30 centimeter I want to find out the potential difference. So of course you will be knowing the value of X. Okay, now what is this V by L? This V by L. Okay, this V by L is very important. You see, V by L is in length, unit length, how much the potential is going to drop. In unit length, how much the potential is going to drop. Now for this particular wire, this V by L, this thing is constant. Okay, this V by L is constant. This is known as, here I am writing V by L, it is a constant. It is known as potential difference per unit length. Potential difference per unit length. Since I have said that the wire is of uniform area of cross section, so the wire is of uniform area of cross section. So whatever is the resistance of the wire, it is constant. So that since the resistance of the wire is constant, so the potential is going to drop uniformly. This is not going to happen. Suppose in this particular, suppose for the first 5 centimeter potential is dropping by 10 volt, and in the next 5 centimeter potential drops by 20 volt. That is not going to happen. Whatever potential drop is going to take place, it is going to take place, the drop is going to take place uniformly. Okay, so the drop is going to take place uniformly, and that is why potential difference per unit length is equals to V by L, that is a constant. Right? Suppose the potential difference between these 2 points is V dash, suppose. So easily I can find V dash. So V dash is going to be V by L into X. Now this thing is a constant. Now how to know the value of constant? This particular value you have to know the where which you are using. For that where how much is the potential difference per unit length, or what is the value of K. So K you have to know how much volt per meter or how much volt per centimeter. Just multiply it with the distance. Okay. So that is K into X. That is your V dash. So this is the basic concept of a potentiometer. Don't just at first dive into all the uses of potentiometer and into complicated circuit. This is the basic utility and use of a potentiometer. How to find out the potential difference between 2 points. If I want to find out the potential difference at one more point, suppose D, and if I see that the distance from here to here is Y, suppose. Okay, and suppose the potential difference is V double dash. So from here I can write V double dash will be equals to how much? K into Y. K into Y, no, K is constant. Potential difference per unit length, that is constant, that is not going to change. So easily I can multiply K into Y. If for one more distance, K into that particular distance. So in this particular where, between any 2 points I can find out the distance. Even if you want to find out the potential difference between these 2 points, just measure this distance. Okay. If you want to find out the potential difference between C and D, okay, just measure this distance and multiply it with K. This K is going to remain constant. That is how you can understand or you can find out the potential difference between 2 points in an electric circuit. Okay. Now see students, since this length, the length of the potentiometer is very large. Okay. So and for certain experiments, for certain devices or for certain experiments, we have to use a very long potentiometer. Okay, very long. Now suppose the length of this particular wire is L centimeter. Suppose L is 100 centimeter. Suppose L is 100 centimeter. Okay. Okay. So in 100 centimeter length, the potential is dropping. Suppose 50 volt. Suppose 50 volt, the potential is dropping. Here I have given the value. Suppose V 50 volt. Suppose. So first you find out the value of K. So value of K is V by L. That means V by L. That means 50 divided by 100 volt per centimeter. Okay. So 50 divided by 100 volt per centimeter. And suppose you want to find out the potential difference at a length, suppose 20 centimeter. Suppose X is 20 centimeter. So at this particular length you want to find out the potential difference. So how to find out? So just multiply K is your 50 by 100 volt per centimeter into 20 centimeter. Okay. So just see, this is 2, this is 10 volt. So we got our answer. That is at a length from here at a length of 20 centimeter. If you count from here at a length of 20 centimeter, the potential difference will be how much? 10 volts. Okay. This is how you can measure the potential difference between any 2 points. Now see, in certain experiments, as I already said, we need a very long wire. Okay. Now if you take a very long wire, it will be very difficult to conduct the experiment. Okay. It will be very uneasy and very difficult to conduct the experiment. So in actual device, actual potentiometer device, what we have this wire, but in the bent form. Bent form is like this. Suppose this is one wire. This is one wire. Suppose of 100 centimeter we take. This is one wire, and here we have a metallic strip, and one more wire we connect over here. Okay, and here again we connect a metallic strip, and one more wire over here we have, and here we connect a metallic strip, and at last one more wire we have over here. Now each of these lengths is equal to 100 centimeter. Now you see, so the total length, how much you got? The total length is 400 centimeter. Now 400 centimeter, if you want to take a straight wire, it will be a very long device and it will be very difficult to conduct the experiment. So we have the device in this form, and now we can connect the cell and battery. Now we can connect the cell and battery. Cell and the switch. Okay, done. So maybe this is your point A, this is your point B. We have the device in this form. Okay, so from after this, the diagrams that I am going to draw, I am going to draw the actual diagram. But first you have to understand the basics of potentiometer. It looks like this. This is the potentiometer and how to measure the potential difference. So in this video, we are going to discuss about only one use of potentiometer, how to find out the EMF of a cell. For that, let me first draw the diagram and then show you. Okay students, so here is the diagram. You see, this is the potentiometer which I have shown earlier. Now over here you have connected one extra thing. Suppose you are given a cell and you need to find out the EMF of the cell. Okay, so this is the cell. Okay, so this is the cell and I need to find out the EMF of the cell. So this particular cell I have connected in this. Okay, this is a galvanometer. A galvanometer detects a current. Okay, if a current flows through this part of the circuit, you can see this entire circuit is actually divided into two parts. This is the main circuit. This one is the main circuit. This is the potentiometer wire. Okay, the main wire that I talked about, the wire AB. Over here, this is one more circuit. This is the primary circuit. This one you can consider to be the secondary circuit. In this secondary circuit, I have connected the EMF of the cell. I have connected the cell. Okay, whose EMF you need to calculate. Over here, you have a galvanometer. Galvanometer detects current. That means if any current flows through this particular circuit, okay, if any current flows through this particular circuit, the galvanometer is going to deflect. Okay, and you know, galvanometer also gives us the direction of the current. If current flows in the opposite direction, galvanometer deflects in the other direction. Okay, now our task is to find out the EMF of the cell. So here we have a battery. Okay, this is a cell. Okay, this one is a battery, this is a cell. Now, two important things you have to keep in mind before starting this experiment, okay, or before understanding this. Whatever may be the potential difference of this is your main battery, okay. Whatever may be the potential difference of this particular battery, the EMF of the cell, you don't know the EMF of the cell, but you must have an idea, the EMF of the cell must be less than that, or else you cannot find out, okay. So this is number 1 point. EMF should be less than the EMF of the battery. Okay, battery means this one, this main cell that I am talking about. So this, suppose this is 50 volt. Suppose this is 50 volt. Now the EMF of this cell, you don't know the EMF, fine, but this must be less than 50 volt. If it is greater than 50 volt, then you cannot find out the value. Fine. Next, number 2. You see, the positive terminal of this cell. Okay, the positive terminal of this cell, I have connected to the positive terminal of the battery. This thing should be maintained. If you connect the positive with the negative of EMF, then this potentiometer is not going to work. Once I explain this concept to you, you will understand. So, positive of E should be connected with the positive of B. So the positive of E should be connected with the positive terminal of B. This particular thing also should be maintained. Okay. Now if you have done these two criteria, we can start. Okay. Now see. This particular thing is known as a jockey. This is known as a jockey, okay? That means if you tap on, I hope those who have done practical, you know what is a jockey. It's a triangular device, and if you tap on that particular thing, the wire divides into two sections, okay? So basically the wire will divide into two parts. So over here, if you touch the jockey, wherever you will touch the jockey, the wire is going to divide into two segments. Okay, now let's see. This particular length, the length of the potentiometer wire, suppose it is L. L is the length of the potentiometer wire. This is suppose V volt, this is suppose 0 volt. Okay. This is a copper wire, I already told you, this is a copper wire. So in copper wire there is no drop in potential. So if this is V volt, this one also is going to be V volt. This particular point is also going to be V volt. This is going to be 0 volt. That means in this particular length, okay, in length L, potential difference is V. Okay, in length L, potential difference is V. So therefore, in length 1, potential difference will be V by L. So this is your K, V by L. This one already I discussed earlier. Okay, this is constant. This particular thing is constant. This is constant. Okay. Now, how to find out the EMF of the cell? You see. So the basic concept. See, you have to understand the basic concept. The basic concept is over here we have connected a galvanometer. Okay. Now, first, let us think that you first what you have to do. This particular jockey you have to touch at various points in this wire. Okay, the jockey will be touching at various points in this wire. Now suppose this jockey you are touching over here, J1 suppose. Here you have galvanometer. At this particular point you are touching the jockey, and you see that the galvanometer is giving you a deflection. Okay, a galvanometer is giving you a deflection. It means that current is flowing through this particular circuit. There is current through this circuit. That is why the galvanometer is giving you a deflection. Fine. Suppose now again you touch the jockey at this particular point. Suppose this is J2. Here also you will see, suppose you are seeing over here that again the galvanometer is giving you a deflection. That means once again current is flowing through this particular circuit. Okay, so whenever the jockey, or suppose whenever you after touching the jockey, if the galvanometer gives you a deflection, it means that current is flowing through that particular circuit. Okay, now continue searching at various points. You will get one particular point. Where you will see that the galvanometer is giving you no deflection. That means the galvanometer is showing you zero deflection. Okay. So mark that particular point. That is basically your point. Okay, I will be telling you what is the meaning of that point. See the distance from point A. Suppose the distance from point A is x. This is the distance of this point from point A. Okay, find out the potential difference between these 2 points. We know that the potential difference per unit length is V by L. So for x length potential difference is going to be V by L into x. Okay, we have discussed this already. For x length the potential difference will be V by L into x. Now if you find out the potential difference between these 2 points, that basically is the EMF of the cell. That is only the EMF of the cell. Okay, so how is it working? You have to understand the concept behind it. You see, galvanometer is showing you zero deflection. If the galvanometer shows you zero deflection, it means that no current is flowing through this particular circuit. No current is there through this particular circuit. Okay. Now, first you have to answer one question. When will no current flow through any particular part of a circuit? Okay. See, current always flows through a potential difference. Here I am writing. Okay. Current always flows through potential difference. If there is a potential difference, then only current is going to flow. Okay, if there is a potential difference, then only current is going to flow, or else current is not going to flow. Now see what happens. This particular portion you have connected with point V. Okay, this is your point. This is the potential over here is V. So the potential at A is also V. So since this particular terminal, the positive terminal is connected to this point, and this is again a copper wire. This is again a copper wire, and we know that no potential drops in the copper wire. So if this terminal is V, this potential is V. So just come over here. This potential is also V. So this is also V. Okay. Suppose this is 50 volts. This is 50 volts. So this one is also 50 volt. This is also 50 volt. Okay. Now once you cross the pattern, if you are going from the higher potential to the lower potential, so there will be potential drop. How much will be the potential drop? The EMF of the cell. Suppose the EMF of the cell is 20 volt. Suppose You need to find out this value. Suppose for now I am considering that the EMF of the cell is 20 volt. So 50 minus 20 will give you 30 volt. So this one is 30 volt. Okay, this is 30 volt. Now see, as you go along this wire, the potential is going to drop from 50 volt to 0 volt. As you go along this wire, suppose this particular point is 40 volt. This is 40 volt. This particular point is 20 volt, and this particular point is suppose your 30 volt. Okay. Now, when you are searching through, when you are just touching the jockey at different points, what you are actually doing, you are actually touching the jockey at different potentials. You are actually touching the jockey at different potentials. Suppose I have touched the jockey at 40 volt. Suppose I have touched the jockey at 30 volt. Then suppose 20 volt. Then suppose 10 volt. Then suppose 0 volt. Okay. Now suppose if you touch the jockey at 30 volt, you see what happens. If you touch the jockey at 30 volt, then the potential difference between these 2 points is becoming how much? 20 volt. 50 volt minus 30 volt is how much? 20 volt. And the potential difference between these 2 points is also 20 volt. That is the EMF of the cell. So what current will see? You see what current will see? When current is going to flow from here, current will see over here there is 50 volt. Okay, this is 50 volt. This is 50 volt, this is 30 volt. Okay, so the potential difference between these 2 points is 20 volt. The potential difference between these 2 points is 20 volt, and you have touched the jockey over here where the potential is 30 volt. That means the potential difference between these 2 points is also 20 volt. So the potential difference between these 2 points and the potential difference between these 2 points is same. When the potential difference is same, current is not going to flow. Okay, when current will see that I have the same potential, current is not going to flow through this branch. Current is not going to flow through this branch. Okay, because see what current is seeing. Current is seeing that over here there is 50 volt, over here there is 50 volt. Fine. Here there is 30 volt. So current is going to flow through this branch. Current is going to flow through this branch. Here is also 30 volt. Here is also 30 volt. Okay, so this is 50, this is 30, this is 50, this is 30. So through this particular branch, current is not going to flow. Okay, once again I am repeating, this is the most important concept. Okay, so current will not flow if there is no difference in potential. So here also difference in potential is 20 volt, here also difference in potential is 20 volt. In that particular case, current is not going to flow, and the galvanometer is going to give you zero deflection. Okay. So how to get the EMF of the cell? Once you know, as I said, current will not flow if the potential difference between these 2 particular lengths is same. So what will be the EMF of the cell? If you see that current is not flowing, and if you can measure the potential difference between these 2 points, suppose A and C, if you can measure the potential difference between these 2 points, which is this one, V by L into X. So this potential difference and this potential difference is same, because current is not flowing. We know current will not flow if the potential difference is same. So this potential difference and this potential difference is same. So we can say that the EMF of the cell will be V by L into X. We know V by L is constant and X. This will be the EMF of the cell. This is how you can measure the EMF of the cell. Once you know the potential difference between these 2 points, the EMF of the cell is going to be same. That is why current is not flowing. Now you see, in these 2 particular cases, why current was flowing. In this particular case and in this particular case. See, at this point J1 I have tapped into 40 volt. So what current is seeing? Over here potential difference is, you see, 10 volt. Here potential difference is 10 volt. Here potential difference is 20 volt. Okay, here 40 volt and here we have 30 volt. Here 50 volt, here also 50 volt, but here you see 30 volt and here you have 40 volt. So there is a potential difference. So current is going to flow through this circuit, and the galvanometer is going to give you deflection. One more point I am showing you. See, at this particular point, suppose you have tapped into 20 volt. So 50 volt minus 20 volt. You see, this one is 30 volt potential difference between this point and this point. 30 volt potential difference. Over here potential difference is 20 volt. So what current is seeing? 50 volt, 50 volt. But you see over here 30 volt and over here 20 volt. 30 volt and 20 volt. So again current is seeing a potential difference. So current is going to flow and the galvanometer is going to give you a deflection. So at any other point except this one, always current is going to flow through the secondary circuit, and you are going to get a deflection. So you have to search the null point. Null point means where the galvanometer give you zero deflection. The basic concept is the potential difference between these 2 points must be equal to the potential difference between these 2 points. Then only current is not going to flow through the galvanometer. Okay, 50 volt, 50 volt, 30 volt, 30 volt. So current is not going to flow through this part of the circuit. Current is only going to flow in the primary circuit, because current will see that over here only there is a potential difference 50 volt, 30 volt. So I will go through this part. Why I will go down? I will not go down because over here the potential difference is same. So 50 volt, 30 volts. I will go through this part. I will go through this branch. So I will only flow through this particular wire. Through this branch I am not going to flow. Okay. So that is how you measure the EMF of a cell. So just you have to find out the null point and see at how much distance you are getting the null point, and then you can just multiply with K to get the EMF. But you see, one more thing, the basic important thing, as I said, the EMF should be less than the EMF of the battery. Why? Because you see, suppose the battery is of 50 volt. So in this entire wire you are going to get a potential difference of 50 volt. But suppose if I take the EMF of the battery to be 60 volt or suppose 70 volt, so how this wire is going to show you 70 volt potential difference? This wire can only show you a potential difference of 50 volt. If you take the EMF to be 70 volt, maximum EMF it can show is 50 volt. If you touch at this point, maximum EMF it can show you is 50 volt. 70 volt it cannot show you. Okay, so the EMF, whatever it is, must be less than the EMF of the battery. So this is how we can measure the EMF of a cell. I hope the concept of potentiometer is clear to you. If you have any questions or any doubt or understanding any part of this particular video, please let me know in the comment section below. I hope you like the video. If you like the video, please like and subscribe. Thank you.